of cloud security. It's still not comprehensive, but it's close, I think. And my name is Sibtay Shah, and this is my introduction and journey as well. So I started off as a software developer, moved into cloud architecture, DevOps, and then as part of my job, I was doing and still continue to do cloud security. And then I'm just lucky enough to just loop between these 3, 4 roles. So this is what I do on a day-to-day basis. So when we talk about cloud security, the other thing is that I am hyper focused on AWS. So the references that I might be making would be from AWS, right? So when we talk about cloud security, it's very important to understand the shared responsibility model of your cloud provider. So what you see right now is AWS's shared responsibility model. Depending on the delivery model you're using, because using any of these major cloud providers, you could be doing infrastructure as service or platform as a service, right? So depending on the delivery model, the shared responsibility model changes, right? But it is documented, and it's very important to understand what is our responsibility. So as an example, if we are using an EC2 instance, the responsibility of the cloud provider here is to secure the data center, the hardware that's running our EC2 instance. But the security of the OS itself and the packages installed and anything that's running on top of that is our responsibility. When we talk about cloud security, the challenge mainly is scale, because in the cloud era, the scale of how we provision resources and the number of times we provision and the number of people and the kind of roles, that has totally changed, right? Previously, it used to be a centralized team which was responsible for provisioning. Now it's happening all over the place, right? So the scale is the challenge when you want to monitor cloud security. And before we even talk about how we are gonna secure, we need to understand that we need a solution for something very basic but very fundamental, which is visibility or inventory tracking, right? So obviously, the kind of era we are in, we need something that is automated, right? It cannot be done manually. Now, obviously, security is implemented at various layers, right? And we're gonna go into the kind of our layer-based approach. But at the most basic level, we have assets in the cloud, right? Cloud resources or assets. And each asset has a configuration, right? Now, what we need is something that provides an inventory for all our assets in the cloud and monitors their configuration. And if there is any best practices violation in the configuration, it flags. So that is going to provide comprehensive cloud security as far as the protection of our asset is concerned. So here in this example, you see an EC2 instance. And EC2 instance could have security groups associated with them. And for example, it's a common use case actually that a human error would be made and someone is just gonna open the SSH port to the entire world, right? So we need something to monitor things like these, the configuration, and flag them, right? And what that something is called cloud security posture management. That is the industry term for this kind of protection and monitoring. What we are talking about, by the way, is a world of acronyms. So you're going to hear a lot of acronyms, but I'm going to try to simplify, right? And this is one of the things that I want to do. I want to bring all these acronyms in a hierarchy or a structure, right? So yeah, cloud security posture management is exactly what it does, which is it monitors. First, it provides the visibility. It does inventory tracking for us. And then it monitors the configuration of our cloud assets. And for each configuration, it compares against industry best practices. There are frameworks like CIS, AWS's well-architected framework, Azure's well-architected framework, NIST, ISO, all these compliance standards as well. So whichever framework is active, which you want to compare against, so whenever there's a violation, it basically flags the resource, right? This is CSPM for you. We use the same approach to implement actual security and same approach to implement compliance as well, right? So one side note is I see, because I work with a lot of small businesses and startups, I see this behavior that companies are just focused on compliance, which is very important, but in doing so, they are not focusing on real security, right? Being compliant doesn't mean you are actually secure, right? So this is what I try to do in my consulting practice, in basically have people focus on real security at them. Right? An extension of CSPM is KSPM. Kubernetes, since it's such a huge thing of its own, so we have we gave it its own acronym, which is KSPM, which essentially does the same thing, which is configuration, misconfiguration management and drift detection for Kubernetes clusters. Moving on to the next module, and that is identity and access management. Right? If I have to pick one, what would be the most important thing in security? Like the first one, which we will handle, I think it would be to me, it would be IAM, right? Because we could have the best security in place, but if someone can steal admin credentials, none of that is going to be effective, right? So when we talk about IAM, we need to think from the perspective of the life cycle of IAM, right? For example, a person comes in, their identity is, their user account is requested, it's approved, they start using it, their role change. Now they may not need the permissions that they were assigned initially, or they may leave the organization. So we need to have these life cycle hooks to basically, whenever this life cycle event happens, we take the appropriate action. For example, when the person leaves the organization, their account should be deleted, right? So that's one important thing to keep in mind. Now, and this is one of the challenges as well. Some of the other challenges are, if we take the same example, a person joining an organization that has multiple cloud accounts, right? Which is very common these days. Even smaller companies are gonna have multiple cloud accounts. You have an organization and you have an account for specific, let's suppose, environment, staging, production, dev, right? So now for this person, you would need to create an account in their in the organization's directory space. You would need to create an account in all of their cloud accounts, right? You would need to create accounts in, this is the bad implementation, right? The worst case scenario. You would need to create an account for all the applications that the organization uses, right? So obviously this is something which doesn't work, doesn't scale. It's a maintenance nightmare, right? So we need something centralized, and that is where we have identity federation, right? And one of the implementation of that is through SSO, single sign-on, right? So besides, in addition to the cloud security module, which I'm going to talk about now, this is one thing that needs to be in place in order to efficiently manage identities, right? The other challenges are old and forgotten identities that are just there lying around. People have left the organization but are still there. A lot of the breaches happen through the AWS secret key and access key just being exposed, right? Being in source code, being on locally on people's computers, right? So that's a major challenge. And the other challenge is excessive permissions. Even in mature organizations, I've seen or people struggle with implementing. We all talk about implementing principle of least privilege access, but in practice, I haven't seen it a lot, right? So that is another challenge. Okay, you start, and I'm complicit in this. Someone is doing something. I need this permission, that permission. After a few, back and forth, we just give him admin permission, and then that's it. And he just has the admin permission forever, right? So we need something which basically monitors. So one thing that we know is that initially people will start with some level of excessive permission, right? But over time, once we can identify their pattern of usage, we could have something that could monitor the permissions that they have been using and just create a permission policy that just includes those actions, right? And then we need something which continuously does that, because over time their role might change. They may need more permissions, or existing permissions need to be removed, right? So what is that? That is called cloud infrastructure. It's a long word. Entitlement management, right? CIEM. So it exactly caters to these challenges that I mentioned. Besides the centralized management, which obviously is handled through identity federation, right? So a CIEM solution is basically going to, I'm not going to repeat, address those challenges that we just mentioned. In addition, these solutions also provide anomaly detection. So now you have something that is able to track user activities. You just throw in machine learning there, right? And you are able to identify the pattern. And if there is any anomaly against that pattern, you could raise basically an alert, right? This is a common implementation of anomaly detection in this space. The other thing specifically, some CIEM solution may not do it, but like, for example, if you look at AWS's Access Analyzer, they also monitor any resource that you expose externally, either to like the public or even to external accounts. Those would be flagged, right? And those obviously, like, publicly exposed S3 buckets are a major cause of data breaches, right? So that is another essential function which a CIEM solution is going to provide. Just for completeness sake, I consider secrets management to be also part of IAM. And there would be some topic that I'm just going to skim over, but feel free to ask any question now or during the Q&A session, right? So this is one of the topics that I just want to skim over. Now, so far, we have extensively added protection for the static aspect of our security, right? But what if there was a vulnerability, there was a security hole, and that made its way to the to production, to our running application, and someone exploits that vulnerability, right? So we need something for runtime, and that's where cloud workload protection comes in. You will see the acronym CWPP, Cloud Workload Protection Platform. And what they are doing is basically they inject an agent in our running applications, not application, in our running servers or our containers, right? Most of the modern development, new development is now container based, right? So that's why you're going to see CWPP platforms mainly focus on container, right? But the same concept, same level of security is implemented for VM servers, right? So what they do is they run a container, run an agent, and they monitor the runtime behavior of our application, and anything basically that is abnormal, any rogue behavior, that gets flagged. For example, file integrity monitoring, right? So if you have an application running, and in that application or within a container, someone is trying to modify the etc shadow file, that's going to raise an alarm, right? So another important thing which these runtime protection platform will do is compare the running container with the golden image, right? So if something got installed on the container, then it means there's a drift between the image that the container was ran from, right, and what's running, right? So if there's a drift, something got changed. And same can be applied to VM images as well. This is a like a cultural paradigm which is called shift left security, and the idea is something that has been applied to development, but now it's being applied to security as well. That we move the security monitoring and detection as left as possible, which means as close to development as possible, right? So, for example, what this manifests in is as part of your CI/CD pipelines, you are running static code analysis (SAST). You are running SCA, which is called software composition analysis, and you are, for example, running doing your secret scanning as part of your CI/CD. So any issues, any vulnerabilities, any issues we are detecting earlier before they make it to production, right? Similarly, for container images, for example, you have an image before that gets deployed to production. You are scanning it. If it has X number of vulnerabilities or too many high or critical vulnerabilities, you fail the pipeline right there, right? So you never let a vulnerable image made its way to production. So this is shift left security. There are more topics, right? But I just want to stop here, make a checkpoint, because what we have covered so far is what is included in modern CNAPP platforms, right? So another acronym, Cloud Native Application Protection. This is basically a unified platform that is supposed to provide comprehensive cloud security. Actually, I don't think they do, because unless you include other security checks, right? We don't have comprehensive cloud security, but these platforms include CSPM, CIEM, CWPP, and also shift left security, right? So now when you hear CNAPP platform, essentially this is what they're talking about. Other things are obviously important, and like the providers that provide CNAPP platforms also provide vulnerability management and source code scanning and all of that, right? But by definition, this is what's included in a CNAPP platform. Okay, now vulnerability management. Part of the vulnerability management is basically a big chunk of vulnerability management is patch management, which means it is very traditional, right? Which is, okay, you have you have OS and your packages installed on your servers. They get out of date. There are security patches that need to be basically applied, right? So, but now there is much more to that. Even like if the first thing is vulnerability management is not just patch management, right? They get used interchangeably, but it's not just patch management, right? Vulnerability management could also be configuration management, right? You install Tomcat. Tomcat, if you install it, it's going to come with like its standard example application, right? Which is a security hole into your application, right? So deleting those applications is also vulnerability management, right? But like specifically right now, if we talk about patch management, so servers and virtual machines is the same as traditional, which is you install an agent, the agent checks for vulnerabilities and reports to your platform, right? And then you have vulnerabilities and you can remediate them. But now we also have, for example, container images, and virtual machine images, right? Those also should be part of our patch management, right? You have a container image, new version got introduced. Now you need to update to the new version because your version now has vulnerabilities, right? And same goes for VM images as well, right? Yeah, when you launch a server, it's launching from a virtual machine image. So you would question, why do I need to patch my virtual machine image, for example, with an AWS call an AMI? because when you auto scale, they are scaling from that AMI, right? So even if you patch the servers, now you have new servers coming up which are launching from your AMI. And if your AMI is not patched regularly, they're going to have those vulnerabilities, right? Like I said, this was patch management, but vulnerability management also includes a bunch of other things, right? And this is one of the examples where I'm just listing the things so that we understand where something falls, where things fall, in which specific category. So web application scanning, very common, right? These days, it comes under vulnerability management, right? SAST also comes under that, and also in all the other acronyms listed here. We also need to, obviously, when we're talking about security, we also wanted to cover data protection. Data protection in the cloud world is basically traditional. We do data classification, and once we have classified, we know what is the classification level of our data repositories, and after that we can apply the data security techniques on them. One method for data protection is tokenization. What it does is it doesn't store your data, it stores tokens that represent your data. And then you have a tokenization server or tokenization service which can take those tokens and tell you what data is this token was representing. There other, obviously, the big one is encryption. And encryption, as we all know, there is encryption in transit, encryption at rest, and then there is also a new, to me it's new, I found out recently, that the encryption in use, which is even when the processor is processing and storing the data in memory, that would also be encrypted. Last but not obviously the least is network protection. So in the cloud space, there are some new things that came up, and then there are a lot of the traditional stuff, because in the cloud, the network is virtualized, but the concepts are the same, right? So obviously the first one, which we just talked about, is encryption in transit. The other one is very important, very traditional, is firewall, which also is our perimeter control. So when we are protecting our network, we protect first our perimeter, right, our boundaries. And that is where traditionally we have used firewall, and we continue to do that even today. VPC, the virtual private cloud concept, which basically within a public cloud provider, we get our own private space. That's one way to protect our perimeter, that creates our perimeter, right? And then after that, when we talk about firewall, for example, within AWS, I can tell it's the nickel rules. So basically, at the network and subnet level, we can control what comes in and what goes out using the nickel rules. And then, since we are talking about firewalls, I also want to mention about security groups, which basically are host level firewalls, but you don't need to configure on the servers yourself. You do it like virtually at the cloud provider, at the cloud level, but you associate it with the host, and it functions as a host level firewall. Obviously, very important is network segmentation. So you create your demilitarized zone, and then you have your logical partitioning of your network using subnets. One common approach is obviously using private and public subnet within cloud, right? So private subnets are not going to have inbound access to the internet, which adds a layer of security, right? And then public subnet are the subnets that have inbound internet access. You can also basically cut outbound public access, outbound internet access, but it's like difficult nowadays to not have outbound public internet access. So the other very important and interesting concept that has come from the cloud in the cloud era is basically service endpoints. So for as a service, like software as a service, solutions, they are on the internet, but using service endpoints, you can bring them as under your perimeter. So when you invoke them, when you communicate with them, you're not going to the public internet. You are internally within your perimeter or VPC, you are communicating because now they exist internally using the service endpoint approach. In terms of what techniques are used, WAF, Web Application Firewall, is one for network defense, obviously very important. DDoS prevention, intrusion detection and intrusion prevention systems, egress filtering, like basically you can filter packets or messages going out from your network, and data loss prevention is another of the techniques used for network defense. Okay.
What was the acronym NICL? Can you expand on that one?
Which acronym?
NICL?
It's just like a casual way to say NACL, Network Access Control List.
There you go.
Yeah.
Okay.
Yeah.
Perfect.
So.